Now that the data is clean, we're ready to code up the algorithm. So let's go back to the notebook with Vaishnavi and pick up where we left off, which is exercise 4. Vaishnavi, here's Rachel's algorithm again. Now the only thing it really does is manipulate these tables called T and C. So the main design choice is, how do we store these tables? What do you think?
Well, we don't want to store all pairs if we don't have to.
You mean the table T. That's reasonable. So for our language data, it's unlikely that all possible letter pairs will occur often. In other words, the table is likely to be sparse. That means that many of the entries will be 0 and therefore don't need to be stored.
Yes, that's the reason I like dictionaries. The key will be a pair of letters and the value will be the count. We would only create an entry if there is at least one item pair.
Otherwise, you can assume that a missing entry is implicitly 0. That's a clever way to exploit sparsity. By the way, that reminds me of a special kind of Python dictionary called a default dictionary. A common pattern is updating values for an existing key. But the way Python dictionaries work, if the key doesn't already exist, trying to update its values will cause an exception. That means you always have to write code that checks for the key first. It's not hard, but it is ugly. Now, default dictionaries rescue you from this pattern by hiding the check. They're defined in the collections module. Vaishnavi, maybe you can give us a quick demo?
Sure, I'm happy to. The first thing you need to use a default dictionary is a factory or a function to create initial values when the key does not exist. In these examples, the initial value is 0. To use a default dictionary, you need to supply a function that, given no arguments, creates 0 values.
Yes, I see you have an example here. Calling int with no arguments produces a 0, which is exactly what we need for counts.
Exactly. To see how it works, take a look at the next code cell.
Oops.
It shows 2 updates, one to an existing key and one to a new key. When you run it, you can see that it does not throw any errors. Instead, the new key gets the value of 1.
Ah, very cool. I think that's exactly the right tool that we're going to need to complete exercises 4 and 5. In exercise 4, you're given the table called T in the algorithm. In this code, it's named pair counts. You're also given a single item set. Your task is to enumerate all pairs of the item set and update the corresponding counts. Now here's a helpful hint. Python's itertools module has a handy function called combinations, which might help you with this part of the task. So go read about it and see if you can apply it. Next is exercise 5. Here, the table named C in the algorithm is named item counts in the code. Again, you'll need to update the counts. So Vaishnavi, let's pause here and give everyone a chance to try exercises 4 and 5 on their own, and we'll pick up with your solutions after the break.